Welcome to This Explainer. Today, we're pointing our virtual telescopes at a subject that for a really long time, astronomers thought they had completely figured out. But spoiler alert, they hadn't. I'm talking about Caldwell 70, also widely known as the Sculptor Pinwheel galaxy. Now, on the surface, this looks like your quintessential, absolutely perfect spiral galaxy. But as we're about to see, this seemingly tranquil island universe is actually hiding some incredibly dark and surprisingly violent secrets. So what happens when a quote-unquote perfect galaxy hides a violent past? You know, for decades, textbooks have used galaxies exactly like Caldwell 70 as prime examples of isolated, simple galactic evolution. The running assumption was always that if a galaxy was just left alone, it would quietly spin, form its stars in a super predictable way, and avoid any major cosmic drama. But what happens when our advanced instruments look a little deeper and peel back the layers of that perfection? Well, the scientific mystery we're unpacking today challenges literally everything we thought we knew about isolated spiral galaxies.
Part 1. Meet the Sculptor Pinwheel.
Okay, let's dive right into this. To really grasp the mystery, we first need to look at its pristine presentation. Caldwell 70 sits in the Sculptor constellation, roughly 6.07 million light-years away from us. That actually makes it one of the nearest large ensembles of disk galaxies right outside our own local group. It was discovered way back in August of 1826 by James Dunlap. It's classified as an SAS spiral galaxy, and it sits at this really convenient inclination of 42 degrees. Basically, that just means we get a fantastic, tilted view of its entire structure straight from Earth. And when we look at that structure optically, it is breathtaking. The visible starlight reveals an absolutely textbook, pure disk galaxy. It's got less than a 2% bulge in its center, and the light just gracefully fades out perfectly all the way to the edges. Based on this view alone, you'd be entirely forgiven for thinking, oh, this is just a quiet, simple, undisturbed spiral. But actually, scratch that. This optical perfection is a total illusion. Which brings us to part 2, mapping the invisible gas. You see, the real story of Caldwell 70 isn't told by the starlight we can easily see. It only begins to unravel when we shift our focus to what's invisible to the naked eye. We have to map the neutral hydrogen gas. Using powerful tools like the Australia Telescope Compact Array, researchers mapped the 21-centimeter line emission of this gas. And they found something startling. There aren't one, but two distinct gas disks. The inner gas disk is dense and perfectly aligned with those visible stars we just talked about, sitting right at a 290-degree orientation. But the outer gas disk, it is drastically misaligned. It's twisted all the way to a 332-degree orientation and stretches a massive 35 kiloparsecs across. To put that into perspective, that's well over 100,000 light-years. It's wider than the entire stellar disk of our own Milky Way. Astonishingly, about 43% of the galaxy's total 1.5 billion solar masses of gas resides all the way out here in this weirdly misaligned, twisted outer disk. And this brilliantly illustrates the sheer physical distortion happening out there. Notice the stark asymmetry. The southeastern edge is sharp and defined, while the northwestern edge is completely frayed. This actually suggests that as Caldwell 70 is moving southeast through the intergalactic medium of the Sculptor group, it's experiencing what we call ram pressure stripping. Think of it like sticking your hand out the window of a moving car. The friction of space itself is physically peeling the gas right away from the galaxy.
Part 3. The Dark Matter Mystery.
So, we have twisted, frayed gas, but the invisible gas alone still cannot explain the internal dynamics holding this massive, sprawling galaxy together. This brings us to a huge invisible player, dark matter. By tracing the movement of the gas, researchers plotted the galaxy's rotation curve. The rotational velocity of Caldwell 70 rises as you move outward from the center, hitting a maximum speed of almost 100 kilometers per second at a radius of about 10 kiloparsecs. But then, and this is fascinating, instead of staying flat forever like you see in a lot of galaxies, the rotation curve gently begins to decrease in the outer disk. This highly specific speed limit acts as a crucial clue for mapping out the total mass of the entire galaxy.
To figure out what's causing the specific rotation, astronomers tested different theoretical models. Alternative gravity models like MOND struggled completely because they just couldn't account for that decreasing outer curve. However, specific dark matter models like the NFW model provided an absolutely excellent fit. They perfectly accommodated the drop in speed, revealing that within a radius of 18.4 kiloparsecs, Caldwell 70 is swathed in a massive dark matter halo that brings its total mass up to a staggering 29 billion solar masses. Now, we really need to talk about the stars hiding out in those very distant gaseous outskirts.
To do that, let's quickly define metallicity. In astronomy, metallicity refers to the abundance of elements heavier than hydrogen and helium in a star. Because heavier elements are forged over generations of stars, metallicity acts as a chemical fingerprint. Generally speaking, older stars are metal poor, and younger stars are metal rich. Simple enough, right?
Well, now, what's really interesting here is how our expectations are just completely subverted. Normally, as you move from the center of a spiral galaxy to its outer edges, the metallicity smoothly drops. It's a negative gradient. And in Caldwell 70, that's exactly what happens, until you hit a radius of exactly 15.5 arc minutes. Suddenly, bam, the gradient flattens out and actually reverses. The stars out there are way more metal-rich than they should be, and they're totally out of sync with a simple evolutionary model. Something dumped a highly unique population of stars way out into the margins of this galaxy.
Part 4. Fossils of a Violent Past. That strange chemical signature in the farthest outskirts of the stellar halo is our smoking gun. It forces us to transition from looking at Caldwell 70 as a peaceful spiral to treating it like a full-blown cosmic crime scene. And here's the stunning conclusion derived from recent deep photometric data. This pristine, isolated disk galaxy we thought we knew so well actually has a history of galactic cannibalism. That's right, it didn't just grow peacefully, it devoured its neighbor.
The forensic evidence left behind at this crime scene is just undeniable. Astronomers found Stream N, which is this massive tidal stream of stars extending more than 40 kiloparsecs to the north. They found multiple stellar shell structures rippling all through the halo. They even found an ancient metal-poor globular cluster sitting a full 23.3 kiloparsecs away. That is the furthest one ever identified around this galaxy. By adding up the mass of all these shattered remains, researchers estimate Caldwell 70 consumed a dwarf galaxy roughly the size of the Fornax dwarf, representing a 1:15 mass ratio collision. Let's move to a timeline and see how this all builds together. Over 6 billion years ago, Caldwell 70 started with classic inside-out growth, forming old stars right in its center. Then, between 1 and 6 billion years ago, younger stars started populating the outer radii. But then, somewhere in the ancient past, this wildly violent accretion event happened. It tore a dwarf galaxy to absolute shreds, created all those metallic irregularities we talked about, and scattered streams and shells across the halo. Finally, the dust settled, and extended star formation out there ceased completely over 100 million years ago, leaving us with the beautiful illusion of peace we see today.
Part 5. The End of Simple Galaxies.
This timeline and these incredible discoveries, they don't just rewrite the history of one galaxy in the Sculptor group, they bring us to a much broader, fundamental shift in how we understand the entire universe. The final verdict is crystal clear. The textbook definition of Caldwell 70 as a perfectly isolated, simple, pure exponential disk, yeah, that's officially dead. It is a highly complex, dynamically evolving system. It's being physically shaped by massive dark matter halos, its outer gas is actively being stripped and twisted by intergalactic ram pressure, and its stellar halo was built by the violent cannibalism of smaller galaxies.
So the crucial point is this. Caldwell 70 was long considered the absolute quintessential standard for an undisturbed spiral galaxy. But if even this perfect galaxy is actually the site of a violent, cannibalistic past, what does that mean for the billions of other so-called simple galaxies hiding in the dark corners of our universe? It really makes you wonder, doesn't it? Next time you look up at the night sky, just remember, in the cosmos, there's really no such thing as a quiet life. Thanks so much for joining me on this explainer, and keep looking up.